Oh, hello everyone. For me, it's been, I think, 2 weeks since I've recorded a video, so it's been a while. But I got a surprise for you guys today. Today, we're doing something special. Not only am I going to be teaching you how to create new ROS packages and their uses, but get this, we're also going to be writing some code today. Whoa, got to get the clickbait phase. We're going to be writing code today. And I'm going to be showing you how to create a very, very basic node that's just going to kind of talk at you through the console. It's going to be great. It's also going to be a longer video, so be ready for that. Prerequisites for this video. Make sure you have watched the installing ROS video, the Unix video. I mean, you should have watched all of them by now, but it'd be like that. And I think those are the only two main ones. But yeah, let's get right into it. So I'm going to go ahead and share my screen with the, with my Ubuntu image. Again, I'm using this image. If you're using some other form of Linux, you should still be able to follow along completely okay. Should not be a problem for anything we're going to be doing today. So the first thing we're going to do is we're going to create a ROS package. And the idea behind a package is it's essentially going to be a collection of the programs we write. You might say, hey, we have a workspace. Why don't we just use that? Well, we want to use packages. It's just kind of like how we're going to be organizing our workspace. So you've got your programs that are inside of packages that is inside of the workspace. So just kind of stuff like that, okay? So without further ado, let's jump on into creating a package. So how are we gonna do that? Well, it's gonna be done through the terminal. So make sure you go ahead and open up your terminal. If you haven't put it on your sidebar here, it'll be down here in the 9 dots, type in terminal, should pop up. And you'll see we got this. So this is where we want to be, at least starting out. So sit in my chair a little bit better. So the first thing we're going to do is we're going to navigate to the source folder of our Catkin workspace. Now you should know how to do this if you've watched the Unix video. But if you're just following along, I mean, you can type in what I'm typing in and you should be good. So we're going to go, I guess we can see where we're at. We're in the home directory. You can see there's Catkin workspace right there. So we can just go cd catkin. Boom, we're in there. And then we've got the source folder, the devel folder, and the build folder. We're going to go into the source folder and boom, here we are. Step 1 complete. Not too bad. The next thing we're going to do is we're going to be actually executing the command to building the package. And I should say, as before, this is not any knowledge that is, hidden somewhere. I'm literally going off of commands that are in the ROS wiki. Again, there's a lot of extra stuff here that we don't really need that I'm kind of brushing over. But if you want a lot more in-depth, ROS wiki is your place to go. So we're going to go ahead and type out the command catkin create package. And then we're going to type in our package name. So we could just do my first package. We'll just go pkg. And now we need to put in what are called dependencies. So when we're going to be running ROS, there's going to be a lot of code that depends on other stuff. If you're a programmer, we're essentially just saying, hey, here's our package. It's going to depend on these libraries. If you're not a programmer, it's basically like, here's a massive chunk of code that we don't need to write. We can just reference it. And we'll say our program is going to reference these packages. So there's 3 main ones we're going to do. The first one is standard messages. So that'll be std underscore msgs. And what those are going to be is it's going to be the types of topics we can have. So if you remember the pub sub video or the raw structure video, which you should watch, we can have publishers and subscribers assigned to topics, right? And each of those topics is going to have some sort of data that's flowing connected to the name. I guess I should say the standard messages is kind of a collection of different data types. So numbers, strings, data objects, that sort of stuff. So we're going to need it. The next one is going to be ROSPy, which is the Python integration package for ROS. So we're going to be using commands and stuff that's going to be from the ROSPy library. And then the third one we're going to add, which we might or might not use, you might use it for your projects, we might, I don't know, is going to be ROS CPP. And what ROS CPP is ROS for C++. ROS is primarily coded through either Python or C++. If you're watching this as a part of the fall 2020 team for RMC, we're going to be using Python. So we're going to be using ROSPy, but you could also use ROS in a C++ environment. The idea is that if we put both of those, we'll be able to kind of use programs that utilize both C++ and Python. Okay, so we've got that. Let's go ahead and hit enter. And oh no, we have an error. Oh no. So what we're going to need to do is source where we're at. Kind of a little thing is ROS is super complicated. ROS has a ton of stuff. One second. I'm going to pause the video really quick and make sure I am talking about the right thing. Okay, sorry about that. I just wanted to make sure that I was, telling you guys the right stuff. So anyway, we need to technically what's called sourcing our environment. So how are we going to do that? Essentially, every single terminal that you open, so if I open another tab, you need to source your Devil folder for your Catkin workspace. So how are we going to do that? Super simple. It's a command that you'll do source, and then we need to get to the Catkin workspace Devil folder. Currently, we are below that. We're in the source folder. So how are we going to do that? We're going to reference the parent library and go into the Devil folder. So if you've watched the Unix video, which you should have, you should already know how to do this. We're going to do ... to reference the parent library. Then we're going to do /devil. And then once you're in here, you can just type setup.bash. Boom. And now this command should work. Boom. It's like magic. It's going to say created file, package.xml, cmakelist.txt. And then it's going to actually create the folder, my first package, and create a source folder inside of it. And then it'll say, hey, I did it successfully. Yay. And it's also going to say, please adjust the values in package.xml. I'll get to that in a second, what that is. But you might be saying, Justin, come on now. If we're going to be sourcing, we have to source every single time. Are you kidding me? I'm going to tell you yes, but also there's a way to make it easier, essentially. So the way we're going to do that is we're going to use a command from this website in ROSWiki, which is the Noetic installation Ubuntu page. And essentially, we need to essentially use this command or the one that we did before every single time we're going to use a terminal. So instead of that, we're just going to source it. We're going to echo source it. So the idea behind this is every time we open up a terminal, it should, if we did it right, use this command and automatically source it for us. So we shouldn't really have to, think about it. That's going to be nice for later on. If you get something here where it's just a weird error and you're pretty sure you put the command in, go ahead and source anyway. That's usually a pretty good first step in debugging, is just making sure that you've sourced your devil to make sure it works. That's about as much as I'll go into that. So let's check out this package.xml. And while we're at it, we can also check out this CMake lists. So if we go over to our file system here inside the image, you'll notice that if we go inside Catkin Workspace, inside the source folder, we now have this package that says my first package, the one that we just created. And if you go in here, you have your package.xml, your CMake list, you have an include folder, and you have a source folder. If you want to go inside these, you can, do whatever you want, look at whatever, but this is where we're going to be putting our programs, will be inside the source folder. So let's look at these files. Now, you can open them up in whatever text editor you want. For this video and for the rest of it, I'm going to be using Visual Studio Code, or VS Code. I'd recommend downloading it on your image and using it. It's very, very simple. It integrates very, very well with GitHub Desktop. So I'd recommend it. Up to you though. Yours probably won't open up to this page, but you can easily get there by going File, Open Folder, go to your home directory here, and you can go to Catkin Workspace, Source, My First Package, and then OK. Okay, and now you'll be here and you'll have a source folder and an include folder. Okay, so first off, let's look at CMake list. Now, CMake list and package, we're not going to be touching too much, to be completely honest with you. We're not. If we go into CMake lists here, I guess you could install a extension to read it better if you want. I'm not going to tell you what to do for VS Code. You just do what you want. And the only things of really to note here are we have this Catkin required components, and you'll notice that we have our 3 dependencies there. If for some reason you're going to be adding another dependency, you'll probably add it there as well. Some random stuff here that don't really care about. A bunch of C++ stuff. Some Python stuff. If we end up using it, I'll make a video on this more in depth, but it's just a bunch of essentially setup for your package to tell Ross what your package is up to. And for the package.xml, this is going to be a little bit different. Again, not too bad. You'll notice that we've got a name of the package, a version, a description, and all of these things you should edit, or you can edit. So you can say, hey, this is the first package I've ever created. You have the maintainer tag right here. So if you were going to be doing updates on this package, you'd put your email and your name. And you'd simply do that by just saying, oh, highlight this and just do my email at, I don't know, internet.com or something. And that sort of thing. And then put your name in there instead of this. So I put Justin. And then our license, again, this doesn't really matter, but you can just go ahead and put MIT. And then we've got some dependencies down here. And I mean, that's pretty much it. If you have a website you want this to go to, boom, you can uncomment this. And if you want to put yourself as an author, go ahead and uncomment that. And the way you'll do that, oh, accidentally highlighted some stuff there. The way you'll do that is, what the heck? Please stop. Oh, it's just lagging a little bit. Unfortunate. It's just by deleting that, and then you can go in there and change the emails and names. Okay. So that covers pretty much the package part of this video. I'm going to go ahead and delete or close these. Won't really need them. Now let's get into the good stuff, the stuff that you have been waiting for. We're going to go ahead and create our own ROS node, our own ROS program. Oh, it's going to be a good time. So if you're using VS Code, all you're going to do is click on the source, click on this new file button right here, and then type in the name. And for this one, we're just going to say annoying underscore node. And then this is the important part, .py. You'll notice that if you're on VS Code that this symbol changes to the symbol for Python. When you put the file extension, that's how VS Code knows what type of file you're doing. Whether it's a .txt, a markdown, C++, you know, etc. So we're going to stick with Py. If you're in a regular text editor or something else, make sure that you have that file extension on there. And you should be good to go. We'll go ahead and hit enter. You'll see it's now inside the source folder. You can install extensions. Again, you do what you want to do. I'm not going to tell you how to code or how to do that sort of stuff. So I'm going to go through the basic parts of a very, very basic program. And I mean, yeah, it's basically it. It's very, very short. The first one we're going to do is literally about 20 lines of code. So it's very, very simple. So how are we going to go ahead and do this? First line, a very, very important line. We need to tell Ross that we're writing in Python. You may think that, oh, it's a .py file. Shouldn't it know? No. So the first line of code in any Node program you're going to do is going to be this line. It's going to be the # or the hashtag, whatever you want to call it, ! /usr/bin/env space Python3. Okay, or whatever type of Python you're doing. And then enter. And what this line is saying is, hey, Ross, use Python for this. Use the Python environment so that we can write in Python and you'll know what we're talking about. The next line we're going to do is import RossPy. So now we can use RossPy commands and RossPy, I guess, functions. Simple as that. Now we're going to go ahead and make our, you could consider it a main method. Your program, but something essentially to just start our program. And if you're going to do, or the way you're going to do that is in Python, at least I may make a video on how to code in Python, but I don't know, we'll see, is you'll do if space _ name _ equals space that _ main, 2 more underscores, that, and then a colon, and then under it, you'll notice that it indents. Indentation is very, very critical in Python. So make sure that your indentation is correct or else it'll get mad at you. Start. And that's basically saying, hey, if this is the main method or if this is the program that's being called with Ross run or Ross launch, go ahead and go to the start method. So let's make a start method. And the way you're going to do that is just a normal method in Python, which is going to be def for define, I guess you could say, or definition, or whatever it actually is for someone who actually knows Python. Start, same name there, and then 2 parentheses, since we're not passing in anything, we don't need to put anything here. And then we're just going to go enter. You'll notice it's indented again. And the first line we're going to do in here is rosspy.init _ node. And then in here, we're going to put the name of the node. And that's going to be annoying _ node. Okay. And now we have this section here. The next part, at least, is the place where we are going to declare variables, subscribers, let me type really quick, and publishers. And we'll get to what subscribers and publishers are in the next video, but if you're a programmer, you should know what a variable is. And if you've taken any form of math, you should know what a variable is. So I don't think I really need to explain that one. Next thing, one of these variables that we're going to create is a message. So we'll do var message equals, and then whatever you want to say. So this one will say, hi there. And then the next one we want to create is going to be a rate. And essentially what the rate is going to do is it's going to make a clock so that we can essentially have our program run every time period or every tick, so that it doesn't like overload stuff, make stuff work too hard, that sort of thing. So how we're going to do that is we're going to do rate equals rospi dot rate, uppercase R with that one. And then we're going to do 10, which is basically 10 hertz, which I believe, if my math is correct, is about a second. Yeah, so that's what we're going to do. And then we're going to need to make a loop that essentially keeps the program running, keeps it alive, that sort of thing. So we're going to do while space not rospi dot is underscore shut down. And what this line of code is doing is essentially it's saying loop this, keep doing whatever we're going to do inside this while loop while rospi is awake or is active or is not shut down. So while our program is still alive, essentially, we haven't killed it yet, run whatever is in this while loop. And that's going to be critical for pretty much any program you write, especially ones that have publishers. Because you want it to publish while it's awake. You don't just want it to publish once and then go to sleep. That's no fun. So inside this, you'll notice it indents again. We're going to do some stuff. This is going to be where your main functionality is going to go. And it's going to end with a rate.sleep, which essentially says stop the program for however long your rate is, right? So that's the line that's essentially saying, don't kill yourself, computer, sleep for a little bit. And then the line we're going to do after this is actually outside of the while loop. So the way we're going to do that is go enter backspace, make sure your cursor is in line with the while here. And then we're going to do rospi dot spin. And what that line of code is going to do is essentially it is going to say if for some reason this gets shut down in a way that's not declared, so we don't do a control C, command C, depending on your operating system to stop it, keep going. So even if rospi does get shut down for some reason, maybe it's a electrical thing, maybe it's a overload thing, this command will actually start it back up, which is very nice and very useful. So make sure you got that one in there, unless you don't need it. The next thing we're going to do is right above rate.sleep, we're just going to do print and then message. And that is that. And that's literally your first node. Congrats, you've done it. It's very easy. So you've got that going. You're good to go pretty much, almost. So let's see what this does. Let's see if we run into any errors running this program, okay? So, open up the terminal again. And what we're going to do is, first thing we need to do actually is compile it. So you'll notice, usually when you program, before you run something, you have to compile it, or when you hit run, it compiles and then runs, and that tells you where you have errors of some sort. So let me show you how to do that. So the way that you're going to do that is make sure you're actually just in your regular catkin. So we'll do cd ... again to reference the parent directory. Go in there, and then it's going to be catkin underscore make. And what that's going to do, I'll kind of walk you through this a little bit, is it's got our base path, the source path, and then the path to I guess, the source, build, devel, and install folders. And then it basically says, hey, it's I don't really care. And then this part, it says traversing one packages. And you'll notice that that's our package. If you have multiple packages, it'll go through each of them. And then here it says, boom, processing package, configuring done, generating done, build files have been written. Cool. That's all we need to do. Now, if I did something wrong, let's see, let's say, you know how I said that Python is really particular about indenting? What if I do like a little like half indent thing here? So it gets, you know, it shouldn't theoretically work. If we do that same command again, it should, what's it doing here? I think it's, what did it do? One second, let me mess this up even more, I guess. Oh, let's just get rid of this line. So we're no longer telling it that you're using Python. I think this should show me what I'm trying to do. Essentially, it should give you an error that says, hey, you've got some stuff that's wrong, but maybe this is just, that's not the, or that's not the output I'm used to, but maybe that's just the output. Interesting. It might just be that I just did it, so it doesn't think that it needs to do it again. That's interesting though. I'll look into that. But that will usually, it'll usually say, hey, there's an error in this file. You shouldn't run it, or you need to fix it. That's where that'll pop up there. So let's see. We need to go ahead and actually run this program, get it to start printing messages, right? So the first thing we're going to do is go ahead and make a new terminal using that button or whatever else it is. And we need to type in a command called roscore. You should just be able to do roscore. And you'll get this little thing, and it'll say started core service. And you'll notice that you don't get this RMC at RMC and then whatever thing here. You just get this dotted thing. And that means that it's running and that you can't type anything in there, or you shouldn't type anything in there. Let it run. If you want to stop it, you can either hit X here, or you can do Control or Command C, and it will kill an exit. Boom. If you get an error here, remember what I said before. First thing you should do if you get an error is go ahead and do a source. You're already in the workspace, so you should be able to do a dot to reference the directory you're in, /devel, setup.bash. Hit that, cool, and then you should be able to run roscore and it'll pop up for you. Cool. Let's see. The next thing to go ahead and do is make a new terminal. And we're going to do a rosrun command. So rosrun is for running one particular file, one particular node, essentially. So how does that look? That will be a rosrun space your package name space the node name. So the package is my first package. If you don't want to type it, you should just be able to hit my and then hit tab. One second. Maybe I need to source because that should autocomplete theoretically. Boom. Now let's try that again. rosrun. There it goes. So make sure you source that. Rosrun, my first package. And then let's see what's in here. Annoying node. Wait a minute. I hit tab and that doesn't do anything. Oh. Let's go ahead and do node.py. Interesting. Interesting. Couldn't find executable named annoying node. Did I spell that wrong? I might have spelled that wrong. Below this thing, it's either not a file or not executable. That's interesting. What happens if I just put in a random thing that's not there? Could not find executable. Interesting. How do you think we're going to fix this? Well, I didn't actually cover it in the Unix video, so I'll probably go back, re-record it, and make a new one. But we need to change the permissions on a file. How are we going to do that? We're going to use the Unix chmod command. And I'm basically just going to show you Very, very basic usage for it. If you want to learn more, I guess you could either watch the Unix part 2 or new Unix, or just look it up. So the way we're going to do that is chmod, which is change, I think it's like moderation, moderator, or you're basically just changing permissions. And then you're going to do a +X for add executable to, and then we need to reference where it is. So we're in the catkin. So we're going to do /source src / my first package /source, because we need to go to the source there. And then we're going to do annoying node, should pop up. Boom, works. Now let's try running that ROS run command again. Maybe it'll tell us what we want. Ahaha. Interesting. So it actually gave me the syntax error here. I'm sure that someone who knows Python is probably just laughing at me right now. Let's just go ahead and just make this message. Maybe it just doesn't like var. I forget. I know too many languages. Save. We're going to go back to the terminal here and do a catkin _make. Cool. Now let's try a ROS run. Hey, look at that. Control C to stop it. What was it doing? So initializes itself, goes through here to the hi there, and then does while not shut down, keeps saying hi there, prints our message. And then it sleeps, which is what that pause was, and then goes back through and prints it again in that while loop until we did Control C and stopped it. So what else can we do now that we have something running? If you're in the terminal, you can do a couple of cool things. 1 second. Okay, sorry about that. Just had to make sure I had this right stuff. So you can go ahead and actually do a couple of commands to kind of see what ROS is going through. And the first one we're going to do here is ROS node. Let me click in here. ROS node list. list. Boom. And that's ROS out, which is kind of like a parent node sort of thing that's always running in the background. So if we go ahead and run our old thing again, go to a new tab, and do, let's source really quick. Boom. And then go ahead and do ROS node list. Boom. You'll notice that we have that ROS node parent one, but we also have annoying node going. If you want a little bit more of a graphical representation, you can use something called RQT graph, which the way we're going to do that is ROS run RQT _graph space RQT _graph. And if it says it's not installed, there's another command, but it should be good to go. And you'll notice now this window pops up and we've got a little annoying node, which says that, hey, it's running. This RQT graph will be a lot more valuable to us once we start getting into a pub sub system. It'll kind of have arrows and stuff going all around, but you know, that's all we really need. If, say, we want to run another one of these guys, let's go ahead and make another thing here. Go ahead and source. Dang it. Boom. And then do a ROS run, my first package, annoying node. So it's running again. And then we do the RQT graph. Give it a second to boot up. You'll notice, maybe it didn't get it. It might just be looking at the one system because there should be two of these. Did I do something wrong? Maybe I did something wrong. But usually there will be two of those because we have one running here and ahaha. Should have said this. It shut down here because there was a new node registered with the same name. And what that means is that this name right here that we gave it, it noticed that there was a second one, so it shut down. In future videos, I will go into something called a launch file, which allows you to have separate, we can have multiple annoying nodes running and give them different names and that sort of thing. But for now, I guess we'll just have to stick with one annoying node yelling at us. So that pretty much closes it for this video. So I'm going to go ahead and stop this here. And then I'm also going to stop ROScore, just so we don't kill a server. And then go ahead and, yeah, you can close out of the terminal, or if you're going to watch the next video, just make sure that you've got stuff kind of going. That should give you a basic overview of how to write a very basic node with some very, very basic functionality, and just kind of be able to use a little bit more of the terminal. Yeah, as always, if you want to learn more, ROSWiki, great place to be, great place to go through tutorials and that sort of stuff. But yeah, with that, I am going to close it here. So if I said anything that was wrong, I guess throw it in the comment section. If you liked this video, make sure to smash that like button and leave a comment telling me you liked it. Make sure to subscribe as well to the channel because, yeah, I got to get that ad revenue, I guess. And you know what, with that, I will see you in the next video.